discussing Andrew Wagenmaker's presentations about learning from experience, which is something that we care a lot about here at Orange Capital Partners. Robots learning from experience, I think, is the future, or in general, agents learning from experience, not just robots. In fact, we could probably at some point decide to call it just agents or robots, and then whether it's digital or physical, the distinction in principle doesn't matter. Of course, it matters technically and sort of from an implementation perspective, but not necessarily at a high level. So what Wagenmaker is talking about here is interesting because he is introducing the idea of posterior behavioral cloning. And the key idea is that instead of having a narrow match between what the person is doing and then train the robot to do exactly what the person is doing, what you want is use the person, the human interaction as a sort of prior to then create an action space in which the robot can operate and then figure out through its own experience how to solve a problem. I think that's fundamentally the idea. So, and I want to relate Wagenmaker's work also with Sutton's oak architecture and the idea of learning from experience. Sutton and Silver, they published an essay, The Era of Experience, which is sort of the follow-up to the bitter lesson. Links in the show notes. And I just want to generally talk about this because I think we're at a crossroads with robotics, because we are, at least we know at this point, and when I say we, I mean not just we here at Orange Capital Partners, but I think also the field in general. I think the path is known. Like, we're not walking around in a foggy environment hoping for Godot here. I think we know what we need to do. Now the question is execution. So, and here's, I think all of these concepts fit together into what we discussed recently in a presentation, and that is pre-training, mid-training, and fine-tuning. So the same concept that worked for large language models is also going to work for robots. It's slightly different, of course, in its implementation, but the fundamental big picture idea is the same. And then we can add the idea, the Sutton's idea, that eventually what we want is learning from experience. And what that means is that you actually, when you run reinforcement learning rollouts, you don't even define the reward function anymore. You just look at outcomes, and you have the robot learn relative to outcomes. What that means is, for example, the goal of the robot is to clean an apartment, and it finds ways to do that without specifically defining skills and getting rewards for skills and things like that. So very similar to humans. You know, if I tell a person, look, go clean my apartment, I'm not gonna judge the person on every detailed action. I'm just gonna look if the apartment's clean, and then have the person figure out how to do that. So again, fundamentally, we are looking at goal-oriented tasks. We're rewarding the robot for achieving goals and have the robot actually learn the task itself. And I think Wagenmaker's approach is more of a low-level robotics solution, but it morphs into the same direction. This is Not Even Wrong podcast. It's May 14, 2026. This is Delco. For the year, we are up 6%. The market is up 9.2%. We're underperforming by 3.2%. Andrew Wagenmaker is a postdoc at Berkeley. He works in Sergey Levin's lab. He has a PhD from UW. And his work is, roughly the idea is, how can we better use behavioral cloning for robotic learning? And with better, I think the key idea, the way I understand his work, is what are the things we can learn from imitation learning, and then how can we bridge the gap between what people are doing in imitation learning and the actual experience of the robot when it's doing work because we always will have sim to real mismatches, morphological gaps, and we'll also have, even if everything matches up, the robot will never have the exact same environment like the person that it's learning from. This is akin to if you want to learn jiu-jitsu from from uh, from our jiu-jitsu master, and you watch his videos, you will never exactly encounter the same situations like the jiu-jitsu master. But what you can do is you can kind of learn the action space. You can learn, okay, these are roughly the movements I have to make. So I don't have to randomly go on the mat and try every possible move and then hopefully somehow morph into the right moves. I have a rough sense for what I need to do a triangle, or I don't know, if I watch Charles Oliveira and I see him take somebody's back, I have a rough idea of what the action space is, and then I can learn from my own experience on the mat drilling how that actually works. Now, this concept, this idea, is what posterior behavioral cloning actually means. It just means that instead of matching one-to-one what imitation learning delivers us, we are building a sort of a distribution space of possible actions, and then have the robot learn within that distribution, to have the robot learn through a reinforcement learning algorithm how to actually achieve a goal. Now, I want to add something here, which is not what Wagenmaker is talking about, but I think our idea of pre-training from video at internet scale actually matches really well into this idea, because if you in principle, if you can learn, if you can have a model train itself on billions of hours of human action videos, you have a similar pre-training result like you have a large language model. So you have a certain amount of knowledge now. You have a limited action space from the almost unlimited noisy space that a model could have if it has no pre-training. So every possible action, there's an infinite possible action in the real world. If you train on billions of hours of human action data, so you've trained on people, cleaning apartments, you've trained on people welding, people fixing stuff, people screwing screws, all that kind of stuff. You have now to use Wagenmaker's nomenclature, you've created a noise policy. So you have a sort of posterior behavioral cloning data set where you have, okay, look, given the real world and given all the possible actions in the real world, we've now pre-trained our model so that it has a much more limited action space. Now, it's still very noisy, but all the actions that it's been trained on, let's say it's trained on a sort of transformer architecture, so it's using mask, matching and things like that, self-attention, all that stuff. Let's say it has a good sense for like where the action space lives given the situation. And we trained this on billions of hours. Chances are that we have encountered a lot of situations. So we have, I guess, in latent space, you have a certain amount of intelligence now, a certain amount of knowledge that is physical knowledge of how to relate to the physical world. And then we do the mid-training. The mid-training would be, in the case of physical AI, would be, okay, now given all of that, what we're doing is we're teaching the robot how to actually weld this piece of metal, or how to clean a Tesla Cybercab, or how to replace a battery cell, and so forth. And that can be done within, let's say, within a reinforcement learning framework. And most importantly, also, the robot can now function do these things, let's say in the Tesla factory, and it will not just walk into the factory and randomly do things. It has already a pretty narrowly determined action space. And if we could add some, maybe, language action model on top of that, so we can also have some semantics, the robot will be pretty narrow in its action when it, let's say, tries to replace the battery. And what it's now going to do is it's going to learn from its own experience with its own physics and its own morphology. It will, through try and error, learn how to replace that battery. But it will not be very messy. It will be very fast. It will have a very efficient learning process. So this is, I think, this is where we see the match between our sort of frontier model, which is again pre-training, mid-training, and fine-tuning, and Wagenmaker's approach. There's some correlation there. I think it's highly likely that this is the way the field will go. And I think what's exciting for us is I think there's two things. I think one is that we have actually a roadmap now. We know what needs to be done, and there's a lot of work also in academia on actually solving the problem, particularly the pre-training problem, which is actually making it making it work that you can train from internet scale video data. That in itself is, of course, a very difficult task. People are working on it. It's in a sense also much more an engineering problem than an AI problem. The AI part comes when you're now taking that, the engineering of transforming videos into action models and then have them train on a transformer architecture. And then, of course, the translation into mid-training, which is apply that to a reinforcement learning algorithm. And then hopefully be able to train the robot to actually execute useful tasks. I mean, that's the end goal. Now, we mentioned Sutton also in the prelude, and I just want to come back to Richard Sutton, who in our opinion is still the most important researcher in this field, even though he's not showing up in too many conferences and all that, although he was at Neurip. So there's something going on there, but very interesting because learning from experience is fundamentally what robots should be doing. And what that means is that you could have a stack where you start with behavioral cloning at internet scale data from videos. Then you use the posterior behavioral cloning approach by Wagenmaker to actually create an action space in which the robot can then explore. And then you add the oak idea or some similarity, like Sutton is proposing, where you take the robot's action and you have it learn while it's pursuing its goal. That's the key, pursuing its goal. So we're going from a task-oriented system to a goal-oriented system. Now we can also add, of course, ideas of like tool use and agentic, coordination tasks and things like that, which all also can be added on top of that. So I think the field, again, like I said before, I'm repeating myself, but it's very exciting. Like we have a roadmap now. We know how robots can actually become very useful agents. The roadmap is there. It is pre-training, mid-training, fine-tuning, and the posterior behavioral cloning is, I think, a very important piece of the puzzle, which can be augmented with, training at internet scale data from video, and then have the robots learn from experience on their own, because with a narrower action space, actually, that is, this could be done with model-free online reinforcement learning, which is the most direct way for a robot to learn. Thank you.